we're here today to listen to this story about how you take Monolith and bring them into the more modern integration platform world. And thanks to Adriano here, we all know what a monolith is now, right? But what exactly is an integration platform? Well, I mean, this is one way to look at it, like a technical component that we actually like plug into our infrastructure, and then we connect everything to it and start integrating, and it works, right? Sure, that's one way. But we can also look at it more in a more like soft way, that it's our policies, it's our processes, it's our regulations, it's in how we actually build integrations. Sure, also true. Another way would be to look at it from a more organizational way. We can have teams that are dedicated to building integrations or supporting the development of integrations. And I think that definitely there is the combination of these three perhaps is the best way to look at this. So with that in mind, I just want to shortly present myself. I'm Per, and I'm normally part of one of these platform teams helping and supporting other teams. Come from Irori, which is a consultant company here in Stockholm. We basically mostly work with these three areas, doing platform engineering, feature implementation for businesses, and also work a lot with streaming data and especially Kafka-based solutions. And I've been working with these three for about 15 years, mainly in the banking sector. But let's go back and look at the monolith world, perhaps in the good old days, like 20 years ago when I started working. This was a pretty common scenario how they looked. There were a couple of them, and they integrated with each other using file batches. So you sent a couple of files, perhaps nightly or something, between them, and yeah, it all worked. And I mean, files are they are slow, but they are pretty easy to understand. You could kind of like see them actually moving between the systems, and you can open them up and look at actual data flowing. So they are like tangible in some sense, but they are also, of course, very slow. And it's still not that uncommon actually to integrate with files. I'm currently working with migrating our banking infrastructure from on-prem to GCP. And right now we are struggling a bit with having FTP brokers running in Kubernetes in a good way. It's not exactly what it's built for. The big difference if we fast forward to today is that we also need to handle something like this. We have a lot more integrations, we have a lot more involved components and techniques, and also our internal systems is much more connected to the outside world than it was 20 years ago. So we have this long list of requirements here. We are using microservice, at least some areas. We are integrating in real time and not during the night. We have a lot of different techniques involved. It's not just one program language, for instance. We're making data-driven decisions, so we need data to be present at much more locations. And as I said, we're integrating a lot more with the outside world, which of course also increases the security requirements that we have on our systems. Both, talking to the outside, but also with zero trust and those kind of things, also within our own environment. So it's kind of obvious when you look at this requirements list that we need more and better solutions and processes to handle this. But before moving into the solutions part, let's try to just like break out, what are some general aspects of an integration platform. And I kind of landed at these three, just not to have that many. And let's start with autonomy. I think that is all about being fast. So we want our teams that work with this to quickly understand and to be able to develop and change integrations without being blocked by lack of external resources. And that can be, for instance, people or teams external to us, or information or decisions that needs to be taken outside of our own team. Security. Well, it's all about, reducing risk. risk that data or functions are accessed, created, deleted, or removed in an unauthorized way. So here it also comes in like DDoS protection, having audit logging, that kind of stuff. Versatility, with that I mean like feature richness. It's all about quality, having the right tool for the job. Different integration scenarios will require different technologies to be able to work properly. So this basically becomes our tool belt when we build integrations, and it's kind of hard to build a house using only a hammer. So you need a tool belt. And I mean, so far so good, no problems. But there also exists a lot of oppositions between these three. So for instance, the more you lock down and put security constraints into your solutions, well, the harder it will be for the teams to work fast and autonomous in their free solutions, and they will have less freedom and agility, and things will go slower. Also, if you pack in a lot of different options when it comes to what kind of tooling you can use, it will might become harder for them to use them in the correct way, and also the security aspects, of course, that needs to be checked will increase. So it's kind of a fine balance between these three, and you have to work with that in a good way. There doesn't really exist any silver bullet answer, and as we all know, it very much depends. But it's kind of a boring answer to end with. It depends. So let's try to find some common do's and don'ts, how to handle this. So if we start with autonomy, I think what you definitely should do is put a lot of love and effort into designing your data interfaces. And that's not only like your REST APIs, but also if you work with more asynchronous integrations to your like models and informations, how you work with that. And this is of course to create a loosely coupled environment where you can change independently without breaking other parts of your solutions. It could be also, of course, to use documentation techniques like OpenAPI or Async API and those kind of standards. But also really importantly, to start from the scratch to design for evolution, to design for that your interfaces will change, because they probably will at some point. And if you have done some kind of thinking of that before, then it will be a much easier job to actually implement that also. Another thing that we should do is to try to have automated self-service development process. Self-service meaning that each team can do what they want to do without being blocked, as I said, by external people or something, needing to do stuff for them to be able to go forward. Yeah, and automate as much as possible, especially where you kind of see that, okay, now we're doing this over and over again. You see the patterns. Automate it because machines are very good at doing this kind of repetitive tasks. We should also try to define as much as possible in code. This, of course, is true for infrastructure that we need to build, but also for like central modules or configuration blueprints that come over and over again. And as you might also know that, documentation, when it is in some external system, they're very often not correct anymore because code has changed, but the documentation has not. So code is often the most true documentation. So that's why it's also good to have it working in code. And talking about who is doing what, well, we see some kind of models when it comes to that also. There is the more like centralized model where we have perhaps a central integration team that like gets tickets from the rest of the organization for building this kind of integration or that kind of integration. And this team will of course be, experts at the actual techniques of building integrations, but they will seldom be very good at the actual business behind the integrations that they build. So they won't have the domain knowledge that the actual teams will have. And most often I think that this kind of teams or this setup will be hard to scale correctly, and they will often become like a bottleneck in the development process. Another like extreme is the opposite, that all teams are by themselves basically building their integrations. And here of course we get a lot of autonomy because they can just work, but you will also get a lot of duplication when it comes to solutions, knowledge, learning, that kind of stuff. It will also be very hard to enforce principles throughout the organization, for instance, security. So I think that the winning choice here will be some kind of mixed model where you have a platform team that acts more like an enabler for building stuff to the teams. The platform team can have skeletons or blueprints, templates, pipelines, of course, but they can also run central components like API gateways or message brokers, that kind of stuff. And they can also be part of defining principles that the other ones could use and have tooling and pipelines that enforces those principles. All right, so autonomy, what should we try to avoid? Well, one thing is, and goes back to the data interfaces, to not expose more than you need, and quite often you see implementation details leaking into your interfaces, and that can be very hard to then change whatever you have exposed later on. So try to not expose too much. And also, as mentioned, I don't think centralizing the implementation itself to a central team is a very good pattern. Yeah. So moving on to security, what should we do there? Well, I think it's important to have some principles that we design and agree upon, and that's mainly in these areas of authentication, authorization, how we do encryption, what kind of patching frequency do we use, and so on. And the easy part here, which I also heard on the keynote, is to make it really easy to make it right. And here again, the platform team or the platform capability comes in to make it easier, for instance, to handle certificates, make it easy to have a open OAuth infrastructure that the teams can use, and so on. So it must be easy to do it right for this to be possible. But it should also be very natural for everyone to follow these principles. Another consequence of using microservice as an architecture is, of course, that you will build a lot of components, and especially if many of these components are exposed externally, you kind of have the issue of keeping all of these components up to standards when it comes to security. So here is a really good point where you, for instance, have an API gateway or something fronting these microservices, and then you'll have less components to care about when it comes to keeping them patched and keeping the security standards up to speed. Also, I think it's important to do some kind of analyze the risks and threats that you have, and decide where you should put the most effort, because it's kind of hard to do everything everywhere when it comes to security. So you need to take some time to actually think about this, because otherwise you won't have any time to do any implementation. You'll just be, nagging down security features all over the place. And just as a side note on this, as I told you, I'm working on building a bank basically on GCP, and naturally, of course, all the infrastructure that we build, we are having in code in Terraform. So I kind of did some kind of estimation of how much of this Terraform code is only about having more features, and how much of this code is about securing whatever we built. And it's, I don't know, somewhere around here. So it's extremely extremely much you need to put down in security. So that this was a kind of, you could have 100% here if you didn't do some kind of analyze. Okay, where should we actually put our effort? So security, I think, is a especially hard area because you don't really know how much is enough. You don't really know when you're done. So you need to kind of like have some kind of pragmatism into this also. Yeah, so what should we avoid when it comes to security? Well, I know we talked a bit about previously also about zero trust, least privileges, and those kind of things, which are really good things, but they are, for me, they are more, an intent, a way to go. It's not that we should take them to like the extreme, because you can pretty much land on trying to, for instance, how fine-grained should we do the IAM for our service accounts that deploy infrastructure in GCP? You have to have some kind of playroom for them. You can't, just put them exactly where they need to be when it comes to IAM. So, yeah, again, a lot of fine-tuning here, but don't take it to the extreme. Also, naturally there are components that are more vulnerable to in your infrastructure, and components that are more locked in somewhere that you could perhaps have a more easy going when it comes to the trust parts. Another thing that I've seen that I don't think you should do is to build your own security components. I've seen examples where teams have implemented on token validation or authorization frameworks. They are almost always already exist. So yeah, don't do that. Versatility. So what should we do here? Well, I think we should have a elaborated strategy and platform when it comes to asynchronous integrations. We mostly talked about APIs and RESTful integrations, synchronous things, but for instance, Apache Kafka or some cloud-native alternatives are really useful, I think, also. Classic EIP or enterprise integration patterns, I think, also is very relevant even today. I don't know if you've seen them some time before, but they look something like this, and these are, the patterns that you normally stumble upon when you do integrations. And this is kind of old things, but they are still relevant today. So if you're doing some kind of integrations, you're probably doing one or many of these ones. What shouldn't we do? Force integration into wrong protocols. I've seen a lot of examples where you build synchronous integrations, where you should have be much better off doing asynchronous integrations. For instance, polling when you could just wait for being pushed, and so on. And also forget about the real world. Things go wrong, as we heard. I've seen example of having calls integrations being made to some external system, and then when you time out, you think, well, then I can just retry. That will be fine. And then you retry a couple of times, and then you land up with creating like 3 or 4 accounts in a banking system where you should have just created one. So think about that. Okay, to wrap it up, we definitely will see more integrations being built, especially with the rise of the AI things. And also a lot more focus on security also, as we already heard. Yeah, so with that, I hope this presentation gave some kind of ideas, and thank you.